What do you guys think about right angles? Are they all congruent or not? They are? Why do you think they're all congruent?
Sorry for the interruption, but teachers, the health department is in the faculty room giving flu shots, and they'll only be there for about 10 more minutes. Thank you.
I already got mine. I cried a little. Easton cried a lot. Okay, so you guys think all right angles are congruent. What makes you think so? What's that? Their measures are all equal to 90, so they got to be equal to each other. All right, so we're going to look at page 106, okay? And we're going to kind of look at this proof. This is what you call a two-line proof. Oh, excuse me, the top one right there is actually what we call a flowchart proof. And I think you're going to like these quite a bit, okay? Because you can see how the logic flows from one statement to the other. With a two-line proof, as long as you set it somewhere up above, then you can do the next thing down below anywhere you want. And then sometimes it's just like, where did that come from? But with a flowchart proof, you see an arrow coming from where that last step was, and so it kind of helps you follow the logic along, okay? Hey, cover the nose up, though. Okay. So, this is proving the right angle congruence theorem. So this is something you're going to add to your reasons. All right angles are congruent, okay? But we're going to prove it first. These proofs we're going to do, they're very, very simple, and sometimes they almost seem like they're postulates, like, well, of course all right angles are congruent, but this one, there's actually a couple of steps in there, and so it actually is a theorem. So, given angle 1, everybody looking at example 1? Angle 1 and angle 2 are right angles. See the picture of them? Prove that they are congruent. Okay? So here's the flow chart proof. They have a little box that says angle 1 and angle 2 are right angles. That's given. So notice your statement is inside the little circle, okay? And then your reason is underneath. And then that leads us to the thought, so if we say they're both right angles, the next thing that leads us to is their measures are 90 degrees. So you'll notice in the next block it says both of their measures are equal to 90 degrees. And that's the definition of a right angle. Do you have that in your reasons? Definition of a right angle? Okay. So if you're told something's a right angle, if you want to say, oh, its measure equals 90, that's your reason. Okay. Now, when they both their measures equal 90 degrees, then you'll see that their measures must be equal. The measure of angle 1 must equal the measure of angle 2. What's our reason? Transitive. That's right. Okay, they both equal the same thing, so they have to equal each other. And then, if their measures are equal, then they have to be congruent. Now, you don't have to go through this whole process anymore. Okay, we've proven now the right angle congruence theorem. So anytime you know this angle's a right angle and this angle's a right angle, what do you know about the two of them? They're congruent. Not really their measures are equal. That would be another step, remember. Okay, but you can say that they're congruent, and you just say right angle congruence theorem. Okay, so you'll notice the two-column proof right below it. All the same statements, all the same reasons. Which one do you like better? Which one? The flow chart? I think you kind of will, because you'll be able to follow the logic through a little bit better. And I think it'll be helpful for you. Okay, let's look at the bottom of the page. Let's see if we can figure this out a little bit. Given segment AB is congruent to segment BC, and segment DC is perpendicular. Sorry, did I say congruent? What's that upside down T mean? Perpendicular. Okay, so they intersect at a right angle. So those lines are perpendicular. Prove that angle B is congruent to angle C. Aren't angle B and angle C both right angles? So they have to be congruent, but how do we know they're right angles? What type of angles do perpendicular lines form? Right angles, right? So see the box that underneath it says definition of perpendicular lines? Okay. What are they saying up in that box right there? Well, actually they're going to say that angle B is a right angle. And they're going to say angle C is a right angle. Or I guess we could just say it all together. Angle B and angle C are both right angles, definition of perpendicular lines. Do you have that in your reasons? Definition of perpendicular lines? They form right angles. So now that we said that they're both right angles, the next statement in the little circle says angle B is congruent to angle C. Isn't it the right angle congruence theorem, right? Right angle congruence theorem, which you already put in your reasons, right? Right angle congruence theorem. Okay, now I'm going to do a proof for you, and you're just going to follow along. I just want you to watch and think as much as possible, okay? And see if you can get this. This isn't something that I would expect you just to come up with on your own or anything, okay? But it's something I think that you should be able to understand at this point as I do it, okay? So here's angle 1. Here is angle 2, and angle 3 I'll draw over here like this. Angle 3. I should have arrows on the ends of these because they're all angles. So here's what we're given. Angle 1 and angle 2 are supplementary. What does that mean that they're supplementary? Their sum is 180, right? Okay. And also, angle 3 and angle 2 are supplementary. So that's what we're given. 1 and 2 are supplementary, and also 2 and 3 are supplementary. Here's what we're going to prove. That angle 1 is congruent to angle 3. Not that their measures are equal. We might have to say their measures are equal, but we want to actually say at the end that they're actually congruent. Okay? So this is the congruent supplements theorem. And it says if two angles are supplementary to the same angle, then they're congruent. It almost reminds me of the transitive property a little bit. What do you think? Is it kind of the transitive property? Kind of the same idea, but they're not both congruent to the same thing, but they're both supplementary to the same angle, so that they have to have the same measure. And if we just think about this for a minute, and whenever you do a proof, you want to understand it and think, yeah, that's true, right? Hey, you looking? You paying attention? Okay? So, say for example, this one's 30 degrees. What's the measure of angle 2 got to be? 150? Well, if that one's 150, what's that one got to be? 30. Okay. So you can see that it has to be true, but we don't want to just prove that it's true when this one's 30 and this one's 150 and this one's 30. We want to prove it's true no matter what their measures are. Okay? Regardless. So it's a lot harder to do the proof. So, should I do a flowchart proof or a two-line proof here? And I think I'll do the flowchart proof so you can see what I'm talking about here. So I'm just going to say angle 1 and angle 2 are supplementary. That's given. And then I'm going to say angle 3 and angle 2 are supplementary. That's also given. Remember, your statements are inside the box, your reasons are outside. Okay, so I just want to think about where that leads me to. Let's see. They're supplementary. What is the next thing you think about? Well, if they're supplementary, what does that mean? They add up to 180. Right, their sum is 180. So I'm going to say now the measure of angle 1 plus the measure of angle 2 is 180 degrees. And of course down here, the measure of angle 3 plus the measure of angle 2 is 180 degrees. In this case, if two angles are supplementary, then their measures are 180. So it's not something where we have congruent in there anywhere, you know what I mean? So I don't have to worry about going from congruent to equal in this case. Does that make sense? Okay, because I'm not saying they're congruent, I'm saying that their measures are 180. So, reason. How do I know that they add up to 180? Yeah, there you go. Definition of supplementary angles. You got that in your reasons? Definition of supplementary angles. Here, I'll put all my reasons in red. What about the definition of complementary angles? You got that in your reasons? What does that say? If they're complementary, then their sum is 90. Okay. Now remember what we're trying to show. We're trying to show that the measure of angle 1 is congruent to the measure of angle 3. And before we're going to get to that, we're going to have to show that they're congruent. We're going to have to show that they're equal. Their measures are equal at some point, and then we can go to this step right here. Okay? So looking at this, I want to make a new equation that involves angle 1, angle 2, angle 3, angle 2. They both equal 180, so what do we know about them? Okay, they're equal to each other. So I'm going to write that down here. The measure of angle 1 plus the measure of angle 2 must equal the measure of angle 3 plus the measure of angle 2. Now I want you to notice that that statement right there came from both of these. Right? So I took both those and I kind of put it together into one thought. It's like you can see the inside of my brain working here now, right? Okay? Reason. Transitive property of equality. They both equal the same thing. They're equal to each other. So that's what we're going to put. The transitive property of equality. Okay. Now I don't want it to say this. I want it to say the measure of angle 1 equals the measure of angle 3. Now, that one says congruent. That's later, but can I somehow get rid of the extra part that I don't want? Yeah, okay. So I'm just going to come down here. You still see? Okay. And I'm going to say, next box, I would go over to the right, but I wrote too big. So the measure of angle 1 equals the measure of angle 3. What's my reason? Subtraction. There you go, subtraction property. Subtraction property of equality. There is no subtraction property of congruence. It's got to be equal. Okay? And then once we have that, I think we can go right to what we actually want, which is that angle 1 is congruent to angle 3. Yep. Definition of congruent angles. This is the congruent supplements theorem. It's not the complete theorem. So listen really carefully. The complete theorem says if two angles are supplementary to the same angle, or if they're supplementary to congruent angles, then they are congruent. So that extra little part right there. In this case, they're both supplementary to angle 2, so they have to be congruent. But there's a little added part. Let's say I know that angle 2 and angle 4 are congruent. And I know these two are supplementary, and these two are supplementary. Then 3 and 1 still have to be congruent. So if they're supplementary to the same angle, okay, or if they're supplementary to congruent angles, then they are congruent. And the congruent complements theorem says basically the same thing. If two angles are complementary to the same angle, or to congruent angles, then they are congruent. Now this is nice because we've now proven this, haven't we? Okay? You can use this theorem now. So this is something you need to put down in your reasons. The congruent complements theorem and the congruent supplements theorem. Although you probably have to prove the congruent complements theorem today. But it'll be almost exactly the same. There's just going to be one number that's going to change in here, isn't there? Instead of supplementary, it'll say complementary, and then right here, instead of 180, what will it say? Yeah, it'll say 90. Good. Okay, turn over to page 108. A paragraph proof. A paragraph proof is where we just write out in words in a paragraph our proof. Okay, so instead of doing all the flow chart or the statements and reasons, we would just write out in words. Well, if angle 1 and angle 2 are supplementary and angle 3 and angle 2 are supplementary, that's given to us, then their sums must both be 180, and therefore they would be equal to each other by the transitive property. And then by the subtraction property of equality, we could state this, and therefore this would be true. And I left out a whole bunch of stuff. But do you see how you could just write out in words a long sentence and say it that way? That's probably the toughest way for you guys to do it. I think you'll like the flowchart proof the best. And I will give you a choice on how you want to do it on the test, okay? So, linear pair postulate. See it? This is a postulate. Do I need to prove it? I see you shaking your head. If it's a postulate, what does that mean? It's simple enough. We don't have to explain it, right? Okay? If two angles form a linear pair, then they are supplementary. What about the converse of that statement? If two angles are supplementary, do they form a linear pair? Look at these two. Look at these two. Are they supplementary? Yeah. Do they form a linear pair? No. So this is one where the converse isn't true, is it? Okay? So you have to be really careful with complementary and supplementary. Supplementary angles, if they form a linear pair, they're always going to be supplementary. But the converse isn't true. And then the vertical angle congruence theorem. Oh, this is a theorem. Vertical angles are congruent. Which ones in that diagram are congruent? 3 and which one? 1, and then 2 and 4. Vertical angle congruence theorem. Let's talk about that one. Maybe we'll do a paragraph proof, but I won't write everything down just to save a little bit of time here. So we're given this diagram, and we know that angle 2 and 3 form a linear pair, so they're supplementary. Is that correct? And we also know that angle 1 and angle 4 form a linear pair, so therefore they're supplementary, because all linear pairs are supplementary. You agree? Okay. Now, if they're supplementary, then I would say that the measure of angle 2 plus the measure of angle 3, the sum would be 180, because that's the definition of supplementary angles, isn't it? Okay? And I think by the same reasoning, we can say that the measure, the measure of angle 1 plus the measure of angle 4 is 180 as well, because, again, supplementary angles, their sum is 180, isn't it? Now, since both of these things equal 180, I want to propose to you that they're equal to each other by the transitive property. Do you agree? And then, dang, I did the wrong one. Do you see how I got down to here? Can I subtract something from both sides and get it to say what I want? I can't. I shouldn't have said that. I should have, instead of 1 and 4, I should have said 4 and 3. Are they a linear pair? Okay, they're a linear pair. Then are they supplementary? So their sum is 180? So right here, instead of 1 and 4, would you guys mind it if I put 3 and 4? Would that be okay? So we'll put 3 right there. All right, now we're in business, because now I have the measure of angle 3 on both sides of the equal sign. What can I do with it? Yeah, so now by the subtraction property of equality, I can subtract the measure of angle 3 from both sides and simply say that the measure of angle 2 is equal to the measure of angle 4. And if I really wanted to, I could even say that angle 2 is congruent to angle 4. So, what do you know about angle 2 and angle 4? What kind of angles are they? They're vertical angles. And what did I just prove about them? They're congruent. Could I prove the same thing about 1 and 3? That's a giant mess. There we go. Much better. Okay. Are you starting to feel a little bit better about proofs? At least you can understand them when I do them. Are you getting to that point? At least if you can follow along and understand the logic as I do it, then we're good. Now here I just spoke and I just made my argument, didn't I? Okay. Now if we were to write down what I said, then that would be a paragraph proof. Got it? Does that sound fun? Yeah, I don't think so either. Writing it as a flowchart proof or as a 2-line proof is going to be quite a bit easier. All right, so now we prove that vertical angles are congruent. Look over at example 4. I wonder what must be true. Ashlyn, I wonder what might be true in example 4. What do you see that might be helpful? No? Anybody? Aaliyah? Well, we just talked about vertical angles, didn't we? Are you guys all on page 109 on example 4? We all in the right place here? We got the two lines intersecting. We got the vertical angle marked at 148 and 3x plus 1. What do you guys know about 148 and 3x plus 1? Yeah, they're equal. So can you solve for x? Yeah, and then once you have x, you know, actually, we don't need to use x to find the measure of that missing angle. We already know it's 148, don't we? All we'd have to do is look for x in that case. Okay. Let's look at a paragraph proof over on page 110. There's a pattern that looks like something from a sweater or something. You guys see it? Okay. Argyle socks. I don't know what they are. Write a paragraph proof. So, given angle 1 and angle 4 are congruent, y'all see 1 and 4? Okay. Prove angle 2 and angle 3 are congruent. What do you think? if angle 1 and 4 are congruent, what do we also know about 1 and 2? Are they congruent? How do you know? Vertical angle theorem. You got that in your reasons? Vertical angle theorem? What do we know about angle 4 and angle 3? How do we know? Vertical angle theorem. So we're given that 1 and 4 are congruent. We've just proven that 1 and 2 are congruent and 3 and 4 are congruent. Can we use the transitive property to say that 2 and 3 now are congruent? We can, can't we? Okay? We got it. How about this one? Let's just talk through it. So I have these two lines, and this angle right here is a right angle. That's what we're given. Given angle 1 is a right angle. Okay? Do you think we could prove that angle 2 is a right angle? Let's think about it for a minute. Are angle 1 and angle 2 a linear pair? So is there some 180? And we already know that angle 1's a right angle, so what's its measure? 90. So they both add up to 180, and this one's measure is 90 degrees, so isn't this one's measure 90 degrees? So isn't it therefore a right angle, because that's the definition of a right angle? Now if I wrote that completely out, what I just said in words, that would be a paragraph proof. Okay? A flowchart proof, now I'm just going to slow down now. Here's what it would be. Angle 1 is a right angle. That's given. What do you think the next thing is I want to say? Yeah, I want to say that their sum is 90, but I think first I better say angle 2 and angle 1 form a linear pair. Now these two statements are kind of separate statements. One doesn't lead to the other. So I'm going to say this is just the definition of a linear pair. And then I can say, the measure of angle 1 is 90 degrees. See how that thought leads from here? Okay. And then down here, I'm going to say the measure of angle 1, I'm going to have to say angle 1, angle 1 and angle 2 are supplementary. All linear pairs are supplementary. Now if they're supplementary, what does that tell us? Yeah, good. The measure of angle 1 plus the measure of angle 2 is 180. That's the definition of supplementary. Now, can we put these two thoughts together? I'm running out of room. Okay, what did I just do? Right here, I replaced it with 90. So what is that called? Yeah, substitution. Substitution property, I'm running out of room, of equality. And then, can I subtract 90 from both sides? Okay, so now I come from here and I say the measure of angle 2 equals 90. That's the subtraction property of equality. And then that would lead me to Hey, angle 2 is a right angle. Definition of right angle. Flowchart proof. Try to leave yourself some room so it doesn't look like mine. I wrote on one side of the page and flipped it over and wrote on the other side. That didn't work out well. Okay. Are you ready to try this on your own? I can see from the fear in your eyes that you are. Chapter 2.6. Don't worry, it's not that bad.